Hey, welcome back. This will be episode number 9 in my robot video series. Getting a little tired, so I'm going to try to finish this out in about 2 or 3 more videos. Um, so we've made the program. We go and poke the e-stop button and all that good stuff. I've taught you about configurations and how to protect the robot from crashes, and you can still crash the hell out of it, but how to keep it from doing wacky things and understanding why the configurations are important and all that good stuff, I hope. So if you are not good on that, go back and rewatch, and hopefully I'll maybe make more sense the second time. We'll see. So back when we made this work object, I really intended to make a second unit here, a second work object, and I also need to explain to you how to get that sort of calibrated back out to the real world so that we can actually push the e-stop button and not miss it by a mile or miss it by whatever. So let's go ahead and just work on this system a little bit and make a second work object and kind of make a little bit more of a program, and then we'll wrap stuff up with pushing on into integration and actual hardware and where you get with real stuff. So let's start making another part here. Alright, so I'm going to head back to my Home tab and then my Layout tab, which is where I remember this from the first videos, a couple videos. I haven't been here in a while. I got my tool. There's my controller. This is, some sort of maybe smart geometry, but you can put whatever you want in here. Bring in CAD files, all that stuff. So I'm going to copy it and see if I can paste it. It doesn't want to paste. Oh, Lord. So let's use ABB's equipment, and it's a, oh yeah, this will extra show what we want to show. Dual cabinet. Okay. So go on this tab here, grab it, and let's move it somewhere. It's just somewhere completely weird and arbitrary. So we've got a second controller here, second and third technically. Move it out, make sure the robot can reach it. That's not the kind of problem I'm trying to solve right now. So we've got similar controllers, but he's in a completely different part of the world. So I don't want to go and reteach all my process points that I would have around this controller, machining holes in it or welding seams on it or whatever it is I'm doing to this, made up device. So I've created some work objects, or at least I created this work object a few episodes back, and so I need another work object over here, and that'll hopefully let me push this e-stop button without ever telling it where this controller's e-stop actually is. So I can come, whoops, wrong way, and go back over to paths and targets, other, create work object, and this will be, I'll just call it work object 2. We went through all this before, so I'll just pick my value, pick the same point that's nice and easy to get to, and whoops, this silly thing. There we go. And the rotation's fine as is. It's going to the right spot, so whoops, I messed that up. I thought I was messing that up. Let's create it again. Data. Position, you gotta highlight it, click it, OK, name it 2, create. Okay, so our work object's here, it's the same as this. So now I need to reference my points from this object instead of this object. So the best way to do that, a couple ways to do that. Let's go ahead and sync this over to Rapid. That's the way I'm going to do it. We want both of these to go. And path 30 I could care less about. That was just playing around. So make sure this is all good. Now we head over to Rapid, open up our push e-stop program. So we go down, we do that, we push it, we end up at target 1. So now let's go over to, let's see, where are we at here? We've got target 1, we've got target 2, and target 3. So we can make it from 1 to 3, no problem, without hitting anything. And let's go ahead and configure that. And let's see, what else do we need to do here? Got our target, so we'll go to 30 after that. And those were defined initially before we had any work objects, and so that's why we're using the world work object, which is not necessarily recommended, but It's fine if you're okay with reteaching a few of these points, or if you know you'll be able to get the robot close enough. So now we need to basically do the same thing we did here. So we'll come and get move here, this guy here, plop him right after that. Once he's done with controller 2. Back home, we'll go back through 30 here, and then back to 10 just for fun. And let's see if this works. I think I know what the answer is going to be to that, but let's find out. Oh, I didn't change my my work objects. So let's just see what happens. He goes there. Oh, he goes back here. Oh, he pushes the button. Well, that's cool, but I didn't change my work object, so I just crashed the hell out of the robot. Here, though, so when we first go here, let's start robot to stop. So here, we need to tell it its work object 2. So we're saying still put the pyramid tool on there, but go to work object 2, go to work object 2, wait there, go back from work object 2, and then we're back to work object 0. So let's try that, head on back here. Pushes the first one, he's moving to 30, moving to work object 2's E-stop button, pushes it, heads on home. So that's exactly what we wanted. And so what else is cool about this? Come on. Okay, let me head home and stop. So what I can do here now, you gotta be careful with this synchronize again. Let's synchronize back to the station, make sure everything's up to date. Good. And I can take this guy and move him over a little bit. So actually I didn't move the work object, so they're not really attached together. I think there are ways to do that, but let's, instead of doing that, let's make it easy on ourselves. Modify offset position. We'll translate in the Y direction 50 millimeters, or let's do it 250. So he's moved over now, and so to match up, let's move the work object over. Boom, modify work object, position, and then I can click him again, or I can just add 250 to this value, but I'll just click him again. Come on. Did you not do it? Oh, I'm on the user frame. Here. I think it's doing it, I'm not sure. Here, I can do it this way. Save some time. There we go. I moved it. That's fine. That's good enough. So we'll sync it back. None of these are going to change anything. But here, let's just do it like that so we don't screw something up. So we just sent the work object over. We made no other changes. We didn't do anything like that. And we should go hit that button, hopefully. Hit the first button. Come on back and hits the second button. So if that's not already kind of obvious of why that's useful, you know, we just have 1 point here. But if we had 50 points, or we had 100 points, or we had 1,500 points, all doing something, you know, writing your name on here with a Sharpie, or, you know, whatever actual industrial thing you're trying to accomplish, you don't have to program those paths twice. And more importantly, you don't have 2 sets of paths to maintain. You've got just the 1 set of paths to maintain. And as this thing twists around and moves, or the part gets fixtured differently, all of your points that you taught are relative to that fixture. That's a solid piece that's not going to change. In this case, just the corner of our cabinet. But as long as it's something you can teach with the robot, what you do in the real world is once the robot's sat down, you tell it with the pendant, typically you'll jog it over, and and put a pointer or something like that, and point at the origin of those points, and then it says pick a point on the x-axis, and you move it just on the x-axis and pick that point of the controller, which would be here, or rather, sorry, x-axis would be over here, and then you would pick a y-axis point and a second point usually, and it just it puts this in the real world, and it orients it appropriately. You got to go up sometimes and down and over, and it'll orient it in all 6 degrees of freedom for you. So if you're writing your name with a Sharpie, you're not gonna, because this side of the controller slopes down some, you're not gonna just fall right off. It'll actually, the robot will write along with that angle. So that's all due to that work object and putting the tool frame. And what's the coolest part about it is it's backing all those kinematics back through the tool that's completely defined by you, the coordinate systems, all the way back to joint positions at this first joint. It's moving them with sub-millimeter precision. Sometimes repeatability is incredible, accuracy is pretty good. So anyway, it depends on the robot. You got to think about all that when you design systems like this. But essentially, that's the gist of programming here with robots. Hopefully that was helpful, and I basically just wanted to get across everything that I wish somebody had told me when I started robot, and really I had somebody to help tell me, but I didn't record it when they told me so a lot of this stuff and help me get through it. But you just really got to read the manuals, and I mean, most of these concepts are the same, so you just hit the manuals and say, I need a work object, how do I accomplish this in Fanuc, or how do I accomplish this in Kuka, and go through and just figure out what piece of code or what piece of software or what you have to do to define these things. I mean, the concept of tools and jogging and all that's basically the same for all these 6 degree of freedom, 6-axis, 4-axis. Even the deltas are the same. They just have less degrees of freedom, or at least these deltas controlled by robot controllers are. So anyway, that's it for that. I think I'm going to do one more video on kind of the moving from here to a working system, which I don't have a working system, but just how that'll go. So I'll see you on that one in a few minutes.